Okay, so the pigeonhole principle, let's do some questions. So the actual principle states if there's more pigeons than pigeonholes, then there must be a hole with at least 2 pigeons in it. So there are 5 pigeons and 4 pigeonholes, then there must be at least 2 pigeons in one of the holes. We're going to prove this, okay? So you can prove this by doing a diagram and have 4 pigeonholes, okay? And then we're going to put 5 of them in. So if we do 5 divided by, now it's not by 4, because, by at least 2 pigeons, If I do 5 divided by 4, then if you look at that, I've got 1 with a remainder of 1. So that means I need to at least put 1 pigeon in each hole, okay? And then my 1 that is the remainder that is left over, so when I leave this over, that 1, sorry, I didn't mean to do it like that, it was meant to be a highlighter. When I do that one there, that one then must go into one of the other holes, so I can be certain that that one has at least 2 pigeons in it. Now, once again, like I could put them all in the one hole, but there's still at least 2 pigeons. I could put 3 in, I could put 2 in one and 2 in the other. But the least amount of times I'd need to draw this would be 5, because I draw out the first 4, and then when I go plus 1 and I do the 1 more, then one of the pigeonholes is going to have at least 2 pigeons. Okay, so let's just look at the socks. A drawer contains only red, white and black socks. How many socks must be selected to ensure that at least, that should say 2, it is 1 pair, because a pair is 2. At least 1 pair is drawn out. Now, just note what I just did then. A pair is actually 2 socks. So what are your choices? Well, you only have red, white and black socks. So if you drew your things, you would have red, white and black socks. So we're going to keep drawing here. So we draw 1 sock out, and we're just going to get 1 of each colour, because that's the if we get 1 of each colour, basically what we're doing is that we want to have what is the, when would I be certain that we'd have 2 of each colour? Okay, so if we get 1 of each colour, that would be 3, because there are 3 colours. See, that's our choices. And then all I have to do is add 1. So if I add 1 more, I will get 4. So if I draw 4 out of there, I can be certain that there'd be at least 1 of each colour. I mean, I could have drawn out 2 reds first, and then a white, and then a black. But even within that, I've got 2 of each colour. But if I want to be certain that this happens, then I would have to do the choices, which is 3, and then I just add 1. So let's look at the next one. How many cards must be selected from a pack of cards to ensure that 2 cards have the same suit? So there are 4 colours, not 4 colours, 4 suits in a pack of cards. So that means that your choices are 4. Okay, so there are 4 suits. And how many before I can be certain? So if I do 1 of each colour, 1 of each suit, hearts, diamonds, spades, clubs. So if I get 1 of each of them, then I would only have to go 1 more, which is 5. So 1 more than my choices to be certain that at least you'd have 2 cards of the same colour. I just want you to think about if we had at least 3 cards of the same colour, okay, then that would mean, you got to think that 3 cards has the +1 on it. So if you did 3 cards, if you want at least 3 cards of the same colour, you take away 1 and you get 2. You've got 4 choices. If you want to do 3, you would need 2 in each of the pigeonholes, 2 of each hearts, diamonds, clubs and spades. So instead of 1, you'd be putting 2 in there. So that would be 4 times 2, which is 8. See, it's still a multiple of 4, and then you would have to add 1. So you would have to do that 9 times to be certain that there would be at least 3 cards of the same colour. Now, let's just say we didn't do 3 and we did 4. If we had 4 of the same colour, then that would be, like if you had 4 of the same colour, you would have to put 3 in each hole, and then you'd have to add 1. So it's 3 times 4, which is 12, plus 1, you'd have to do 13. Prove that a group of 400 people, in a group at least 2 of them will have the same birthday. Okay, so how many birthdays are there? So in a year, there are 365 plus 1 for a leap year. There's actually 366 birthdays, aren't there? Because you've got to include the leap year people, because they definitely have a birthday. So if you look at that, if you did 366, that's your choices. They are your pigeonholes. So 366 pigeonholes. Then if you did 360, you would get 1 and you would have leftover. So you would actually have 34 leftover choices. So if you want to have at least 2 of them with the same birthday, you would have to choose your number of choices, which is 366, and then plus 1, which is 367. Now, since 367 is less than 400, then at least 2 of these people must have the same birthday, because you can be certain after 367 that 2 of them have the same birthday. So let's look at the next one. So prove that in a group of 13 people, at least 2 of them have the same. So they have this. At least 2 of them have the same birthday in the same month. So if you think about that, and you've got 13, all right. So how many months are there? There are 12 months in the year. So that means your choices are 12 months. And because it's at least 2, you would need to put 1 in each of those 12. There's 1, 1, 1, 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because that's the 12 months of the year. So you got January, February, March, etc. So that would be 12. And if you go 1 more, then you would have 13. So because there are 12 months of the year, you would need, if you had a group of 13, at least 2 of them would have the same birthday, because it will be on the 13th one that you would have the extra leftover. Because you would, if you have 1 of each month, then the next one would be 1 more plus 13. Of course, you could have all of the first 12 could all be in January, but that's still covering that at least 2 of them have the same birthday in the same month. So now just looking at, for this next one, we're going to look at them having the same birthday. So we're not talking about months, we're talking about birthday. So there's 366 birthdays, different birthdays. So that there is your choices. Okay, so if we want at least 3 of them, then 3 take away 1 is 2. You would need 2 in each pigeonhole. So you need 2 for each birthday. So that would be 366. If you times that by 2, that would be 366 times 2. You get 732. And if you did 1 more than that, you would have 733. So because that is less than 1,100, you can be certain that in this group at least 3 of them will have the same birthday. So how many words would have to be on the page of writing? So this is a page of writing. So that at least 4 words have the same starting letter. So how many starting letters are there? That would be your choice. So the starting letter is your choice. It's always like when you're trying to look at what your choice is, always look at that last word there, starting letter. See, back there it was same birthday. So that's going to be 26. Okay, so if we want at least 4 of them with the same birthday, or the starting letter the same, 4 words, then if you did 4 minus 1, that would give you 3. You need to have 3. You need to do 3 of each, so 3 in each pigeonhole. So if you did 3 times 26, you end up with 78. Okay, so you end up with 78. And then if you just went one more than 78. See, we have, if I was doing this, you'd have 26 different letters, A, B, C, D, all the way up to Z. And in each of those, you need to put 3. Okay, and 3 lots of 26 is 78. And then if you did one more, then there would be at least 3 plus 1, in one of them. There'd be at least 4 in one of them. So to be 78 plus 1, you'd have to go for 79 to ensure or be certain that this would happen.